So get our packages, the data. Then we created a subset which we use for the regression, which is this one. And then we can go and do the quantile regression. I explained the quantile regression is such that because the data is not normally distributed, and we have seen that with the regression that we did, the linear regression, the OLS, we may want to have normality across different parts of the distribution of the dependent variable. So you realize that if you take the distribution there, we have the far right and the far left. And the far right will be for higher values. The far left will be for lower values. And the middle part will be for the average of the values. So in a typical setting, it means that if you have your data, your business data, your marketing data, your sales data, on your far right, you are gaining. It is good for you. But it can also go to the far left, which is not good for you. And both ends are extreme deviations. If you use your data, your OLS regression to go through the middle, you are losing a lot of information that you may need to take decisions. So it means that you're unable to capture the situation on the ground when things are going very well for you, which will be on the upper quantiles. And if things are not going well for you on the left, on the lower quantiles, you are unable to capture that. Okay. So if we're able to form several regressions, we can understand our relationship in that sense. So what the package that we are going to use is the Quantreg package, so Quantile Regression. And we saw this sequence before. We want to split into any number of quantiles that we want, but it should be informed by, say, the size of your data, the length of your data. But if you split into too many quantiles, each quantile have a smaller number of data points. So you don't have to split it into too many quantiles. You have to split according to the size of your data. There's no specific rule. It's also according to the quantiles you want to study. Do you want to break the data into 4 or 5 or 6? And you set the quantiles like that. Also, with this one is a sequence from 0.05 to 0.95, increasing by 0.05. That gives you about 19 different quantiles. You don't always have to do that. You can set your own quantiles with the C option. So you can set maybe 0. How many quantiles? Let's say 0.25, 0.25. You can get 0.5. You can get 0.75. And that should be all. So this is not a sequence. This is a series of quantiles that you want. And is there another one that we can use? 0.75. Yeah, that should be all. So you can set that one as well. So when you go into your equation, you can do that. So where is our regression? The first one here, you look at, so let me take this one out for you. Let's say M1. Is it this? Yes, let's say M1 for today. No, it will confuse the other one. So let's do Q1. It's going to RQ because now earlier was the linear regression was LM, but this is RQ, quantile regression. That's the function. And you can have your price, and we can do what? if we are doing just one regression, then we have our tau equal to tau. So we can choose either tau 1 or the tau. So let's choose the first one. So if you choose the first, means you are going to have a regression of 19 quantiles. So basically 19 different regressions. So if you run this, tau is not found. We didn't run this line, so you have to run that, and then we can come and run this. So the regression is estimated. And if you just want to see it, you can just write Q1. And you see that for every one of the quantiles, we have the respective regressions. Okay. But maybe you don't want it like that. So that's why we try to keep the coefficients together in one file. And we can write the summary of this regression as well, so that we know the significance across the different quantiles. So line 226 will run only the quantiles, and you can save it as a CSV file. I will show you briefly. So once you run that line, you save that, and you can go and look at it. At the same time, your summary, your summary results for Q1 is still there, which can help you to determine the significance or otherwise of your coefficients. So you see that we have for the first quantile, this is your regression. And they will differ. You see that both variables are not intercept, and bedrooms is not significant. You go to the 10th quantile, the same situation. You go to, if you go to the 10th quantile, intercept is significant, but bedrooms is not. Bedrooms is only significant at 10%. So if you go to 15, they are both significant, and the relationships are positive. And realize that as we go along, the relationship may even change from positive to negative along different parts of the distribution of the data. So you have the ability to analyze the relationship across the whole set of the distribution. And you can do that for multiple regression as well. Okay. So I'm going to open the file for you to see. So the summary results also, if you want to save summary results, you can do that as a TST file. So that is this one. You have your summary on the screen, but then you want to save the summary as an object S. So it is saved as S. And if you use the capture.output function, this is in base R, capture.output function, and you can write it as a TST file. So that saves it for you. One other way is that you can just extract the coefficients. So you see you have Q1, which is the same as the Q1 I did earlier. But here we just say coefficient and pick out the model. Coefficients of the model, and that will pick out only the coefficients from the model without all the other descriptive, the diagnostic information. And you can write that one also into a CSV. So if we go into our working directory, let me open the files we have just written. See, we have written QM1 in both CSV and TST. So QM1 in CSV, right? So if you look at This is the CSV file. So we have each of the quantiles all the way, and we have the corresponding coefficients for each of the quantiles. You see that the first one here, bedrooms, is negative, but if you go to the next quantile, is positive. So realize that at the extremes, at the very extreme, when the market is down, when prices are very low, there's a negative relationship between number of bedrooms and price. And that should tell you something, meaning that you don't have to put a lot of effort in getting more rooms if the price is low. Now you can also see all the coefficients and their respective significance in TST. So you have both files that you can work with so that you don't have to manually pick them from the R console or from the TST and paste them. You have the Excel of the coefficients, and you can indicate the significance from this. Okay. What you can also do is to do this in a multiple regression manner. Let's go back to RStudio. So if you come to KM2, for example, see that we are doing the same quantile regression, but in the multiple case. Okay, and let's change the quantiles to the other one, the one that is just 3 also, just for illustrative purposes. So we are using tiles 1. You see that the quantiles will be just 4 or 3. Okay, you have a warning message. It says solution may be non-unique, means that the variables may be too correlated. So what we may do is that we can take one out or leave it because it's not an error. What may happen is that the summary results may not be able to give us p-values. So let's see, they can give us upper bounds and lower bounds to test our significance instead of p-values. So in this case, we are lucky, we got them. So you see that we have how many? 0.25, 0.5, and 0.75 according to the quantiles that we indicated. Okay. And we can save it as a TST file and pick out the coefficients as well and save them as CSV. So what is happening here is that you're able to look at your relationship from different parts of the distribution of the data or for different range of values for the dependent variable. There's another step which we are not doing in this course, which is dividing the data into quantiles for both the dependent variable and the independent variable, which is the quantile and quantile regression. It's another thing that you can do, and that gives you a 3-dimensional relationship because you have 2 quantiles, 1 quantile on the left, 1 quantile on the right, and you have the coefficients. That makes it a 3-dimensional relationship, which is also even better to give you more insight into the relationship.